So now I want to ask some what people would say are big questions, right? What is mathematics, right? We'll get to that really soon here. But I want to ask with a different question first. What can we say about the words that do exist? We just said that again, they transmit meaning, but there's a lot more words than there are mathematics. There are more words than there are numbers. There are more letters than there are numbers. There's more logical context than there are mathematical contexts. Right? If you apply logic to a lot more things than you do calculation. And again, to me, mathematics is proofing, not doing calculating or any sort of computation. But the point being is language is a lot more comprehensive than mathematics. And that should need no explanation. But when can we do mathematics? Right? It's when we have the words to describe it. So what people don't realize is, right, look at the timestamps of all these videos. There's a chunk of from rhythm to algorithm things talking about all these things. Then that language for litigation and integration series, and now back to physics and mathematics with the from rhythm to algorithm series. And so we have to prove logically the words to use to describe the mathematics that is going to be developed. And so that's why there was that break in there. And so it's crazy because you have to do so much work to make such little progress. And we're not little progress, but like literally adding one word or modifying one prefix or one syllable. And this is axiomatic derivation is the highest level of mathematics you can do. But we return to the question, what is mathematics? And right, we talked a lot about base words, right? Now you just, well, what do you say? Mathematics. What is the basis of mathematics? Thematic, right? Literally look at the word mathematics. Mathematic. Thematic. So the basis of mathematics is theme. And so we just derive the basis of all of mathematics. So people say, oh, you can't contribute to all branches of mathematics because it's gotten too disparate. Ha, you used one of the words in my proof. It's it's separated, it's too specialized. Ha, you used another one of my words. And again, all those dichotomistic pairs, those represent the operative words of any sentence you could say that it establishes the basis of that axiom. So again, this is, you guys have already seen this. The academic community has already seen this, but the everyday viewer has not seen this. And when they do, it's going to be, the academia is going to be in a bad place. And at this point, there's absolutely nothing you can do about it. But we derived the basis of mathematics in its entirety. It's theme. And so now revert back to when you were born. What's the first theme? What's the first thing you did? Theme doesn't really apply yet. But again, you categorized. So the first intuition you would have developed as a mathematician, aka an organism trying to survive, is categorization, is to divide this from that. Then to find functionality. This from that, what does this do, what does that do? So then more other words, more specifically grouping. Again, you're introduced into a family or into a group. So grouping is the first word you would kind of use from the intuition of categorization, and then you form sets specific to mathematics. But we have absolutely derived, well, I have derived mathematics. It's literally the basis, thematics. And so what is a theme? A theme is a motif. What is a theme that recurs a lot? A motif. Recurrence, reiteration. And so, right, theme is motif, sensorality identifies motif. So now we've gobbled up all of the logic of mathematics, literally, logically, and linguistically proven letter by letter, syllable by syllable on your computer. And now we've ported all of that logic into linguistics. So now we should be able to find something that we can solve that is super simple, super obvious, in reduced form, and then bam, move on to our next axiom. Because this process will not stop. Right? Keep it in the context. I'm one person differentiating in all of these different subjects, and it will be all to change, like, if I were to live to like 90 years old doing pretty much nothing but this. But again, like, I do this shit so intuitively that I'm limited by the physics. It's a set time for me to do these things, not a difficulty. So I could probably drive, maybe if it takes me 6 years to reduce a proof, maybe 5 axioms. No, I'm not. If I do another 2 axioms in my life, I'd be dumb, mind fucked. But I've already done 3, and so there I get bored of doing mathematics. I've already done. There's only so much you can do, and now I'm doing 360 between the legs backflips, and I can still do those, and those get boring. But sensorality identifies motif. And then so it's like we don't have good and bad, but we have protagonist and antagonist. So what is a protagonist, right? Clear differentiation there. Is it a good guy or is it just the person you resonate with? Is the antagonist somebody that does objectively bad things or somebody you just don't like? And so that was a big porting. Again, porting is extending the logic. But that was cool. Again, I derived the basis of mathematics. And so the base thing, intuition, so categorization and grouping. As I've said previously, I'm not going to repeat the order. But we have to keep moving on. And so what's another form of sensorality or sorality? Again, I'm trying to focus on sorality. How about accessory, right? Accessories. Right? So now we have a clear form of sensorality, sorality. That's syllability preserved at the end of a word that everybody knows, accessory. If you specialize, if you specialize, if you have decoration, if you're exceptional, you have accessories. You're extra, you're accessory. And so it's just like, again, showing and connecting using sorality and speciality in the same logical sequence. But accessories specialize. And now to define even more rigorously sensorality in the negative, we have one of our current working definitions, where we said sensorality is sensorality in space forces. Using another functional definition, but sensorality is animacy. And so if we define it in the negative, what that does is, again, it inverts the logic. I don't know how to articulate it properly, but it inverts the logic, so now we're solving the negative case, right? You grow up, like you go through puberty, but you don't go back to never being existing before. There's always some remnant of you. There was a point in time when you never existed, and there will be a point in time when you're dead. But after you're dead, you still had influence on somebody, even if you were just a fat, overweight piece of shit and you treated your kids like dog doo-doo, you still had an impact on somebody, good or bad. And so you can't take away your impact, right? You can't create a file on your computer and actually erase it completely. So you build up and then you reduce, but you don't go reduce all the way back to zero. And so we flip the logic, and somehow that will make it an easier proof. What is sensorality? What is sensorality not? What isn't sensorial? So continuing the logic into the negative. Well, sensorality is animacy. Sensorality animates. So inanimacy is insoral. Insorality is inanimate. And now previously we used that definition of sensorality with a C is inanimacy. But now we've contained that logic within insorality. And why not insensorality? I don't know, it just doesn't feel right. It's not a word. I just know that it's not a word. Right? Insorality sounds like a word. Insensorality doesn't really. Insense, to make you really mad. Insensorality, so maybe that's a word too, I don't know. But again, just intuitively trying to get to the most poignant jumping points to get this thing done. But it logically replaces sensorality, which is a positive word. What is sensorality? Now we say, what isn't sensorality? And it's insorality or insensorality. We'll see if that does anything for us. What differentiates base from basis, right? To our preposition consideration. Take from. This taken from that is subtraction. And remember, subtraction is a form of division. And so this contributed to that is addition. And remember, we're modifying the logical implications of our mathematical operators. They're not going to change the function of what you do when you put a plus sign or a minus sign. But where do these words come from? What is the intuition? And why, I guess. But let me finish. This proliferated by that is multiplication. And so now I want to ask the question, how many fundamental unique operators or operations exist? Like physically, how many different ways can you actually do something to something else, right? So we just described them in the general, right? Subtraction is a form of division. You take away something, you separate it, you group it, you categorize it, you differentiate it. So then speciality is a form of division, right? Connecting our logical words to our mathematical operators. But so we have subtraction is a form of division, yeah, and then right, multiplication is a form of like fast addition, right? If I say 3 plus 7, right? So I have 3, element of 3 and an element of 7, and I want to combine them. I want to combine them. So now I have 10 things. I have 10 elements. Subtraction, if I have this and I take it from that, you have a very clear base. Right now we're kind of getting into the properties like the associative property, the distributive property, that we're getting into that intuition as to what are these things and where do they come from. And so addition, you're kind of adding this to that, right? Addition is A to B, and subtraction is B from A. So logically there's base in there implicitly. If you're adding something, kind of the first one, 3 plus 7, 3 is your established base plus 7, and then if you have 3 taken from 7, which is subtraction, 7 is your base. So in like a logically, because remember, chirality, logic is one way, and so the order matters. And it's hard for, I mean, I'm doing this on the fly. Can I say anything else right now? But I think we can say there are only 2 fundamental physical operations that can't exist. Something to gain, something to increase, something to decrease. Whether that's addition, multiplication, or exponentiation, which again, what is an exponent then? Well, an exponent is literally just multiplication. 3 to the power of 2. It's the base 3, clearly, how many times? 2. 3 times 3. 3 times 3 times 3. 3 to the third power. And so I think there's only, I'll put a conjectured color on the statement, but I'm virtually positive there are only 2 fundamental physical operations. Right? Protagonist, antagonist, increase, decrease. Exponentiate, so that's too specific, right? It doesn't encapsulate the generality of 2. Positive, negative, push or pull, yin or yang. And so a lot of intuition to say there's only 2 operators that exist based off what I just said there. But we have derived the basis of mathematics, which is extremely cool. We're still modifying this, the implications of just the logical derivation of the mathematical operators, which is such a weird thing to say out loud, because it's such a, you have to be behind the scenes so much in logic to begin to modify what addition or subtraction means in 2025. But here we are doing it for the 3rd time in my lifetime alone, and I'm doing it. And then we're showing sensorality, its reduction in its negative definition, its reciprocal definition is defining it in its negative, and that flips the logic. And so we're working that definition backwards now. So insorality replaces sensorality with a C, and insorality is defined as inanimacy. Again, continue logically consistent. Sensorality with a C is inanimate. And so sensorality with a C is animate, and then we put in front of that. So insensorality, but we're looking for the form insorality is informal, right? And that's kind of the word I go to immediately. But we've connected some prepositions, again, working our way through, making a lot of jumps every single day. And it's like this every day for me. So thank you for watching, and I'll see you on the next one.